Hey everyone, I am recording from my office at school, and let's get right into today's topic, which is the scientific method. So you might have heard of the scientific method. I'm going to go through all 6 steps of the scientific method and also why we use it. And um, all you really need to do is know and understand the 6 steps of the scientific method, but it's a lot easier said than done. So practice. We'll do some classwork on it tomorrow. Important little caveat, little warning. I don't like the word warning. Just so for your reference, you'll be using the scientific method heavily throughout this course and all your future science courses at Mayfield in college. In your profession, you'll be using the scientific method if you decide to go this route. It's something that will come really natural to you. Pondering, inquiry, and then doing an experiment, obtaining results. But of course, we want to get very, very specific when we talk about this. So the scientific method is a process for experimentation that is used to explore observations and answer questions. There are many exceptions to the scientific method, including things that are discovered, things that cannot be experimented on, such as things in space or things that are really, really, really small. So those are included in science, but they don't necessarily follow the scientific method, okay? If you discover something, you didn't go through the steps of the scientific method, you just saw it and it's yours. And then if things are out of the realm of the planet, or if they're really small, again, this is an exception to the scientific method. However, it's still practicing science. And then finally, the reasoning behind the scientific method. It is a means to obtain an answer to a question using a logical process with gathered evidence and the ability to be replicated. So when you practice science and you use the scientific method, something that's really logical, it's something that is replicable too, so that if somebody, for whatever reason, wants to prove that your science works, they can go ahead and replicate the experiment using the scientific method. And again, this will get easier as we talk about it. There are 2 people in charge of discovering the scientific method, and these 2 people are Galileo Galilei and Francis Bacon. They're the co-founders of the scientific method. For those of you who don't know, Galileo Galilei said that the Earth revolved around the sun, and he was proclaimed as a heretic because the people of the town did not believe him and they thought the Earth was the center of the universe. Flash forward like 300 years later, and he was right. So, and then Francis Bacon was an English philosopher who just coined a lot of ideas in inquiry. Asking questions was a big thing that Francis Bacon did, and he basically became famous for asking all these questions and instilling this skill into a branch of academia such as science. So between Galileo from the scientific perspective, Francis Bacon from the method perspective, they are notable co-founders of the scientific method. I'm not sure if they ever worked together in person, but that might be interesting to find out. Using the scientific method. Why do we use the scientific method? Number one, it's organized. A lot of times when you practice science, you don't want to miss anything. Scientific method ensures that you will not miss anything, and it is highly organized. It gets you thinking in this chronological order where you start with something simple like a question, and then you go through different steps in order to help you best answer that question and communicate why that question was important and how you answered it. It is controlled, and this is, controlled is another word for cause and effect. Well, this happened, so we got this result, or this didn't happen, so we got this result. And that cause and effect relationship basically allows for only possible things to occur. And when we say something is controlled, that means that it can only happen within. There are no external factors that will inhibit your research or that will limit what your experiment can do. So, and the last thing is that, as I mentioned earlier, it can be replicated. So if a scientist does not believe your findings, or they said that's impossible, you could never get that, they can do the same exact thing you did if you follow the steps of the scientific method, and then they follow the steps of the scientific method. So the steps of the scientific method, there are 6 of them. You ask a question, conduct background research, construct a hypothesis, design an experiment, analyze data and draw conclusions, and communicate your results. Asking a question is the same thing as stating your purpose. Well, why do you want to know what's going on? Or what is your question? What are you going to investigate? Is the question open-ended or close-ended? Is it a yes or no question? Does it require more research? And why is the question relevant? Okay. So these are things you want to think about when you're asking questions, when eventually you'll form your own experiments. And you want to make sure that you have a purposeful question, some plan of investigation, and then knowing why it's relevant and not, spontaneous or random. Next, you're going to want to conduct background research. This will help you understand why your question is important. Has somebody already answered that question? Is that answer sufficient? Does it need more information to it? There are a lot of ways to conduct background research. A lot of textbooks will allow you to do background research, such as our textbook. But you gather principles, equations, definitions, and concepts that relate to your question. This is very simple to do, and we'll do a lot of practice conducting background information. And you'll have to do this when you write lab reports as well, even though I give you most of the background information. Constructing a hypothesis. Sometimes people say a hypothesis is an educated guess. It most certainly is, but I like to say it is a proposed explanation based on a limited evidence as a starting point for further investigation. I don't like the word guess. I like hoping that we can see more than just a guess, and we can see, well, based on this background information, even though it's limited, we might be able to do more with what we're given. And then forming a hypothesis, again, we're going to use this word controlled. We're going to go into detail about what controlled means, but this, in a way, the hypothesis can only test one variable at a time. So the best way to make sure your hypothesis is controlled is to use an if-then statement. If I drink lots of water, then I will be healthier. Or if I write with a pencil, then I can erase my mistakes. These are hypotheses that control only one variable. And it's going to be really important that we practice only controlling one. And we'll do that sometime this week or next week. And I think it'll be easier when we do the activity. Cool. Designing an experiment. An experiment must have an active procedure. Do this, pour this, drink this, or try this, write this down, time this. These are all active verbs that are not passive. Even things like watch, or rest, or leave the thing for an hour. These are all active steps in a procedure. You never ever want to use passive voice. Again, I'm a science teacher, I'm not an English teacher. So the best way I can explain this is use commanding verbs. And you want to always make observations when you're designing and performing an experiment. Whether that's color, whether that's time, whether that's anything related to the experiment is an observation. And of course, you can't have a biased process. So all experiments must have unbiased process, which means there shouldn't be any prejudice or judgment or, don't use this, use this, because we want to make sure that we're not that we're giving science every opportunity to benefit from us doing this. So of course, analyzing in conclusion, you want to state those observations you made while doing your experiment. What did you notice in the experiment? Did you come to a conclusion? This is analysis, this is concluding. And we are going to practice presenting data and graphing, but it is always helpful to provide numeric or observational data based on your experiment, and the data should be organized. So a lot of the times your data is going to be numbers, or it's going to be visual, or it's going to be just this happened, but there's certain ways that you want to organize that so that your reader or that the person you're telling can have an easier time understanding. And finally, the last sort of step of the scientific method is communicating the results. Organization, super important. When communicating your results, you must present them in an organized fashion. No one's going to want to read or replicate or consider your experiment if it's messy. I mean, I will, because I'm just like a nice person. But that doesn't mean like someone else will say no. And then we'll talk about lab reports next week. A lab report is a fantastic way to organize the details of the experiment while presenting all the steps of the scientific method. Lab reports are going to be a thing that you were graded on in this class. They are totally up for your interpretation, but they need to have all 6 steps of the scientific method and follow a pretty basic format. And we'll get there. So just to review, 6 steps of the scientific method: ask a question, conduct background information, construct a hypothesis, design an experiment, analyze and conclude all factors of that experiment, and communicate your results. Cool, hope you had a nice time. This is my favorite quote of all time by me. Take care, and I'll see you guys when we get back from the long weekend. Peace out.